Hi, in this video we're going to look at the topic of stratified sampling, and in fact I'm also going to talk about random sampling as well, but not in as much detail. This is a GCSE higher topic, and as ever you can find information to help you on my Twitter feed at Mr_G_Walton, or you can follow us at Tupton Maths. Okay, so what we're actually going to look at in this video then, we're going to be able to you will, by the end, be able to describe the differences between a random sample and what's called a stratified sample. You'll be able to explain how a random sample might be carried out and be able to calculate the required proportion in a stratified sample. And this word proportion is key to be able to understand what it is that we're doing here. In fact, it's a very similar skill that you use in a lot of your maths questions. We're going to use the idea of something out of the whole, and you'll remember that you've done that sort of thing in lots of other things. Lots of other topics have involved this idea of something out of something else. So in this first question it says explain what is meant by a random sample and a stratified sample. So we'll start off and we'll look and see what a random sample is. Now, as daft as it might sound, a random sample is exactly that. It's a selection of people from the whole population. In this case, our population is limited to the number of members at a golf club, and it says the total number of members is 454. A random sample is that if we had these 454 people, let's say we gave them all a number, and we put that number into a hat, and we mix them all around, a bit like the National Lottery really, where we pick them out at random. Okay, so it is exactly that. It's a selection of people that we're picking at random, and the way that we can do things that are random tends to be based on some sort of people picking from a hat. So picking from a hat, or you can do it more scientifically using a computer and a random number generator. So random number generator. These are two different ways that we can do it. Old school, piece of paper in a hat, or more high-tech, using a random number generator either on Excel or on a calculator or something like that. You'll be able to allocate everybody a number and do it that way. A stratified sample is where you keep the same proportion of people in your sample as you have in the whole population. So in this case we've got some males, some females, and different age groups here. Now, I'll show you in a second how you work out the stratified sample of each of these different people. But a stratified sample is a sample of people that keeps the same proportion of people in your sample as there is in the whole thing. Okay, let's see if I can show you how you would do that. In the second part of the question, it says that the club secretary carries out a survey of members. He chooses a sample stratified by age and by gender of 90 of the 455 members. Okay, the question actually says work out an estimate of the number of male members in the range 31 to 50 you would like as a sample. Okay, so what we're going to do is look at that. We've currently got 147 people, male members, between 31 and 50, out of a total of 454. Now, I've used that word out of on purpose. We're going to use our good old friend, the divide. So let's write this down. 147 out of 454. Now, we need to apply that proportion, that ratio, that fraction of people, the number out of the whole, to 90. And applying it to 90, we do this. So we end up with a fraction of people, and we're going to multiply it by 90. Now this is going to tell us how many people, or in fact how many males there are out of our 90 people that we can ask in our survey. We use our calculator for this, and when we do that we get an answer of 29.14. Now obviously we can't ask 29.14 people, but the question does say an estimate of the number of male members, so we can round this quite comfortably to 29. Now if we ask 29 people out of the 90, we will get the same kind of proportion as the total number of males out of the total number of people there are altogether from that age range. Now sometimes you're asked to do this across all the different people. You might be asked to work out all the numbers of people to ask, both males, females in different age ranges, and we just do exactly the same thing. I'm going to do one more, even though the question doesn't tell us to. Let's work out how many people we would need, or let's say how many females we would need to ask under 18 to keep this in the same proportion. And we do exactly the same thing. This time there were 10 people out of a total of 454. We want to know, well, we want to ask 90 people. We do this on our calculator and see what it says. And this time it's 1.98, which again we can round to 2. We can ask 2 girls under the age of 18 in our sample of 90 people to keep this proportional. And this is the whole point of this. We're trying to keep it proportional so that the same number of people are asked as there are that make up the whole population. Okay, let's look at this second example then. Here we've got a table that shows some information about pupils at a school, and this is very similar to most exam questions. It tends to be to do with schools and boys and girls and different year groups. It's a standard question. Here it says Kelly carries out a sample of the pupils at Statson School. She takes a sample of 80 pupils, stratified by year, group and gender. Work out the number of year 8 boys in her sample. Okay, so we're interested in year 8 boys. They're here. Let's look at the total. Here it is. So let's think about how we did it again. Okay, so let's see, work out the total number of these. We've got 94 out of 5, 6, 7. And we want only to see how many there were if there were 80. So multiplied by 80. I'm not doing anything different here to what I did last time. Again, we're going to do this on our calculator. Typically these questions are on calculator papers. If the numbers are horrible like this, they'll definitely be on calculator papers. But if it's an easier kind of number that you'll be able to work out, then there's a chance it could be on none. This gives us an answer of 13.26, which again we're rounding to the number, to a whole number, in this case 13. Okay. Finally, the question says explain what is meant by a random sample. Now I'm hoping that from the first example you can remember what this means. A random sample is when you either write people's names in a hat or you allocate a number to each one. In this case we've got 567 people. It might be that you think, well, if I could say any random number that's going to end in a particular value, we might say we'll allocate one of those to each of the people. So say using our random number generator from Excel or from a calculator, for example, we could allocate a different number to a different person, and if that number comes up, we'll pick those people. Okay, so random is simply that. Or maybe easier, get every number and put it into a hat. So give everybody a particular number, put it into a hat and pull it out from there. Perfectly good way of taking a random sample. Okay, next. Here's a little question for you to have a go at yourself, and in this case it says the table shows the age distribution of employees. The company director wants to make a change in working hours, and they're going to send a question out to 100 of the people. Okay, so 100 employees. How many from each group are needed to make a stratified sample? And secondly, see if you can think of one advantage of using a stratified sample rather than a simple random sample. I've not actually explained this, but let's see if you can use some common sense and see what you can come up with. Pause the video now, have a go. Okay, so hopefully what you've realised is that the total here is 1350, and we need to each time do the following sum. So this is 300 out of 1350 multiplied by 100, and you will get some answers. For the first one we've got 22.22, which rounds to 22. For the second one we've got 33.11, which rounds to 33. And then for the third we have 27.77, which rounds up to 28. And for the final one, we have 16.88, which rounds up to 17. So the total number of people we've found here. Okay. Second part, state one advantage of using a stratified sample rather than a simple random sample. Well, if you were to use a random sample, there's a chance that all 100 people might come from the same age group. It might be from the young people in this case, or they might all be between 60 and 65. So maybe thinking about sort of retiring, they may well be having different views from each other. So in order to stop that from happening, we take a selection of people that are representative of the whole population. So the whole point of this, and the key word that we're looking for here, is representative. And that just means that they represent the whole thing. So they've got the right number of people, maybe either from ages or from genders, so that the sample isn't biased. So representative to prevent bias. Okay, perfect. Right, so if you've been taking a few of these videos on board, then you'll notice now that we do some revision cards towards the end. This is your chance to write things down in your own format. This time we're looking at sampling. There are two types of samples. You can have a random sample or a stratified sample. Stratified. Hopefully by now you know the difference of the two. So we've got random and stratified. Random, they're the ones that are just literally picked at random using some sort of random number generator. And stratified, these are ones that are being selected based on the proportion that they are from the whole proportion. So we're keeping it very much representative. Okay, and that was a key word that I wrote down at the end, representative. Okay, hopefully this has been useful to you. As ever, you can subscribe to the YouTube channel to look out for new videos. Good luck in your exams, and if you need anything, contact me on Twitter. Thanks, bye.